A ship leaves its home port on a course of north 38 degrees west at a speed of 48 miles per hour. So let's draw a vector representing that. Measuring off from north, we go 38 degrees to the west, and the velocity 48 miles per hour. After traveling half an hour, the ship is 30 miles away from the port, and the bearing back to the port is south 41 degrees east. So if it's 30 miles away, if we'd gone for an hour, let's say figuring its velocity only went half an hour and went 30 miles, so the velocity, the resultant velocity is 60 miles an hour. Since the ship was only going 48, we know that the current is helping push it some, and so we're going to just draw something to represent the current here, and then back to the port, the resultant vector would be the one that hooks these up, and we know that vector off from south is 41 degrees to the east, so this angle right here. So now this is the current, and we want to figure that out. We want to find both the speed of the current and also the direction. So as I'm looking at this, the one thing I didn't label here, this is 60 miles an hour. So I have a triangle formed by these vectors, by the ship vector plus the current vector equals the resultant vector, form a triangle. I have two sides, 60 and 48, and I don't have an angle, but I can get an angle. So let's do that now. As we look here, this angle is 41. Since this is parallel to this, then this angle right here, the whole thing, is also 41. So this little angle in here, since we got 38 here, must be 3 degrees. So I now have a triangle with side 60, angle 3 degrees, side 48. So I can use the law of cosines. And so we know that the opposite side, c squared, equals the sum of the squares of the other two sides, 60 squared plus 48 squared minus 2 times the product of those sides, 60 times 48, times the cosine of the angle between those sides, which was 3 degrees. So I can figure out what that side, that would give me the velocity of the current. So it's going to be the square root of 60 squared plus 48 squared minus 2 times 60 times 48 times cosine 3. And I get 12.3 about. We are supposed to round to the nearest mile per hour. So the current speed is going to be approximately 12 miles per hour. Now let's see what we could do to find the angle. And as I'm looking at the angle of the current, I could measure off from north here, and so I would want to know this angle right here. Well, looking to see how I might get at that angle, I know that if I extended this line, that this much of the angle is going to be 38 degrees, because I had this 38 down here, and moving with this parallel and extending that side, that would also be 38. Now if I could find this little piece in here and add it to the 38, I would have the direction angle for my current. Well, looking in the triangle, I could find this angle right here, and then it's going to be supplementary to the little angle there that I want to know. So I'm going to find that angle using the law of sines. I'm going to call it theta. So sine theta over 60 is going to equal sine of 3 degrees over, we'll use it to 1 decimal place for a little more accuracy, 12.3. So we know that sine theta is going to be 60 sine 3 over 12.3. So I'm going to get the calculator and do inverse sine of 60 sine 3 divided by 12.3. And I get to 1 decimal place 14.8. So theta is about 14.8 degrees. But wait a minute, if you looked at this triangle, 60 is the largest side, so the angle opposite it needs to be the largest angle, and so it's not 14.8. But remember when I use my calculator to find an angle by doing inverse sine that there's two possibilities. So this is theta 1 and that's not the one we want. So theta 2 would be, it's like my calculator gave me an angle in this quadrant and I want the corresponding angle in quadrant 2. So that's going to be 180 minus the 14.8 and that will be 165.2. So this angle right here is 165.2, but what I really want is the little angle, and it's supplementary, so it's going to be the 14.8. So this little angle right here is going to be 14.8 degrees. So if I add the 38 and the 14.8, I have this direction angle of the current. So the bearing for the current, we're going to be measuring off from north, and we're going to swing around by 38 plus 14.8, so that's going to be 52.8 degrees around to the west.